Hey, everybody. My name is AJ, fractional CPO, CTO with MXP Studios. I'm really excited about today because this is our very first LinkedIn Live event. And thanks to LinkedIn, there's no way to really test and play with these things before you try it. So we're learning by doing right now. And I'm excited to introduce our guest for the day, Ed Martin, who is an expert in digital twin, digital thread with Twin Site Consulting. And, we'll spend the next however long having a really good conversation about what the future of digital twins and digital threads look like. So, Ed, do you want to introduce yourself a little bit? Give us some info on your background.
Yeah, absolutely. So first of all, AJ, thank you for setting this up, and I agree. There's no better way to learn how to do something than just do it the first time. My background, I come out of the world of manufacturing. I was worked in the automotive industry for a number of years in a lot of engineering and management roles. Switched over into technology at Autodesk in 2007. Good grief, that was a long time ago. And was
Feels like
at
really long
Autodesk in the
ago.
manufacturing group, worked a lot with the AEC group, a little bit with the media and entertainment group there. It's a fantastic experience prior to joining Unity in 2017, and left Unity last year to start my own consulting company focused on digital twins, which in so many ways, it's the culmination of my background. My engineering education was in control systems, and it just kind of reinforced everything that I've done throughout my career to this point. And I feel like there's so much opportunity with digital twins now. We're just right at the cusp of achieving the promise on digital twins.
Yeah, I've been hearing about digital twin, digital thread for years. I mean, well before my time at Accenture, that was a thing. And then while we're at Accenture, there was really this push to understand how to fuse IoT data with digital representations of various systems. So, this is a topic that I've really been excited about. And, what I would love to do is first, let's start with some of the foundational information. So digital twin, digital thread, what is it? What's the difference between those two? Let's get started there.
Yeah, it's a really good place to start. I'm gonna say this is my perspective on it, and I like to joke that if you ask 5 people to define what a digital twin is, you'll get 7 answers at least. I'll try to provide clarity though, rather than confusion on them. And I think digital twins and digital thread are related concepts, but they're not the same thing. A digital twin is a virtual representation for a specific physical asset or a system or a process. It pulls in information from different sources. Oftentimes you've got IoT data, like you mentioned. You may be pulling in data from other business systems, scheduling information, all kinds of information, depending upon the use case that feeds into your digital twin. But the important piece is that it is representing something, and you draw an envelope around it. Digital thread, by contrast, is really it's the capabilities that you have in place to feed the digital twin. So the ability to take that piece of data off an IoT sensor on the manufacturing line, or to pull some data out of an ERP database or something of that nature, and to be able to organize and manage that data so it gets to the right place at the right time. That capability is the digital thread. So it's kind of the communication and information framework that's used to support the creation of digital twins. It's kind of like the virtual wiring, if you will. Maybe a way to say is that the digital thread is the thread, and the digital twin is the actual thing that you weave out of that thread. So it's an instantiation of the thread. And if you don't mind me extending the question a bit too, I'd like to talk about what a digital twin isn't. Because I think you and I have probably, and I'd be curious what you've seen here, you and I have probably both seen cases of somebody calling something a digital twin, and then you're like, well, is that really? A classic example is, you maybe scan a facility, laser scanning or photogrammetry, and you provide a virtual walkthrough, and you can put on your VR glasses or whatever, and you can navigate your way through a space. That can be
Mm-hmm.
very useful. It's absolutely a valuable use case, and it's essentially it's remote visualization, but it's not really a digital twin. It's just a walkthrough. And so I think sometimes there's a tendency just with any technology to grab some phrase and then start calling everything that phrase, whether it's AI washing or greenwashing or whatever the case may be. There's
Mm-hmm.
probably a little digital twin washing going on, but hopefully by the end of this discussion that we have here, we can help everybody understand what it is and what it isn't.
Yeah. Okay. So that's a really interesting distinction because I've seen work like you were describing where it's, hey, let's go through and scan a office building, or, let's have a 3D representation that we could interact with the 3D objects. So if you think about aircraft engine that you can interact and blow apart and say, like, here are the different pieces. But, there's definitely some that I work with that didn't integrate with any type of real-time data or even simulated data. And I think we'll talk about simulated data later, but then there were the ones that allowed you to interact with the real world as you're going through it. And I think that was one of the things that excited me the most, is when I saw the fusion of AR and the real world. And we had a visual representation of a factory and pumps and assemblies, and you could go up to it and actually click, and the pump turned on, the
Yeah.
valve turned off, like that kind of stuff. I definitely see as much more in its complexity as well as its fidelity and feature set of just on top of just a visual scan of the environment.
Yeah, absolutely. And that's not to diminish the value of something like a virtual walkthrough or something of that nature. Those valuable use cases, just call them what they are. Use the right terminology. To that point, I think there are kind of three things that really identify what a digital twin is, or it's a useful test. It's not a perfect test, but it's a useful test. First one is, are you synchronizing data from the real world to the twin? So it's a very straightforward. That's a pretty binary yes or no question. The second thing is the digital twin something that is kind of, this one's a little bit more subtle and arguable. Is the digital twin something that is separated from all of your other systems? So if you've got something that's an embedded control system, it's not really a digital twin. It's just an embedded control system. Again, call it what it is. But the digital twin should have an abstraction away from the physical object. And I think the third thing is you need to have some sort of synthesis. You need to be able to, not just flip a virtual light on or off or something, but really you need to be able to combine data from multiple sources so you can start drawing some insights and having some more complex behaviors that the digital twin can understand and be part of. So I think those three things, the synchronization, the separation, and the synthesis, those three kind of are sort of a minimalistic definition of what you really need to have a twin.
I love it. And then, so we mentioned data several times. So what kind of data are we talking about? What's good data? What's bad data? What's important types of data that we should be thinking about?
I think it first of all, I'll say it depends on the use case. So, and we'll get into this a little bit later on in the conversation probably, but whenever you're talking about a digital twin, you have to first say, okay, well, the digital twin's the solution, but what's the problem you're trying to solve with the digital twin? And so depending upon the use case, you will pull in different kinds of data. But I think oftentimes it's typically going to come from one of four places. And I'm bad at doing this because I'll get partway through the four and then I'll come up with a fifth. But we'll roll with that. So the first thing is data from the asset or object itself, whatever it is that you're creating a twin of. And that's usually sensor data that's coming through an IoT network of some sort and you have access to. So that's going to be one kind of data. Second kind of data is really data that describes the object itself in some way, shape, or form. And that could be geometry models. It could be a dynamic model of physical model of system behavior. So a lot of things are deterministic in nature, and if you can incorporate deterministic definitions of those behaviors, that's data. It's a form of data. You can pull data from business systems. So like I said, you may be, for example, having incoming lots of material, and you're going to want to understand something about the characterization of that material, because the material that's going through your process is part of the process. So business systems can be important. Then finally, you've got environmental data. Is it hot outside? Is it cold outside? What's the humidity? Those sorts of factors. Those are the types of things that, depending upon the use case, you can have those different types of data. But it really gets back to what's the use case and what is the data that you need to support that.
Yeah, so let's talk about some of the use cases and maybe specific industries that you've worked with digital twins in, or that really excite you, so we could kind of narrow down the specific data and what they're looking for to solve for and the challenges that they're overcoming. So
yeah, absolutely.
What
I'm happy to do that. Some of these I have firsthand experience with. Some of them I have secondhand experience with through, some of my previous jobs. And some of them are, like you said, things I'm interested in. So it'll be a mix of each. But, so I'll tackle discrete manufacturing first. It's where I came from originally. And I'm going to say there are really two places where you can get value from a digital twin for discrete manufacturing. One is the product itself. Discrete manufacturers produce products that get put in boxes or on pallets or something and shipped out to their customers. And there, the ability to instrument that product with information that can feed a digital twin can pay off in terms of helping the customer, the manufacturer's customer, get optimal performance, reliability, energy consumption, to reduce the total cost of ownership, effectively by having an understanding of how that product is performing out in the real world. You can help the customer optimize their use of that, extend the life of the asset, identify anomalies, incipient failures, all sorts of things. And then, of course, also, it's incredibly valuable for the manufacturer to understand how their products are actually working in the real world. The more complex, the more expensive the piece of the product is, and the more that it's in a business use case as opposed to consumer use case, it will tilt more toward helping the customer achieve value out of the asset. The more consumer oriented it is, it's going to be tilting more toward helping the manufacturer or the brand understand the behavior of their products in the real world. But the first piece is the product itself. The second is, if you're a manufacturer, then unless you have a completely outsourced business model, you're manufacturing things. And so if you have a shop floor and you're producing something, then really anybody who's been in manufacturing, it's a very difficult business, because anything that can go wrong will go wrong. And if you're producing millions of products, it's going to go wrong on almost a daily basis. So the opportunity here is to reduce that level of product variability, improve product quality, reduce manufacturing costs, scheduled maintenance better, predictive maintenance better. Look for correlations of things going on within your manufacturing facility and be able to zero in and identify opportunities for improvement that you're just not going to find otherwise. Because oftentimes, within any kind of manufacturing facility or something, and this applies to process manufacturing too, any one person typically has their own narrow view of what's going on. An operator might see a problem with a product, but isn't going to know what other sources of variation might have caused that. Well, with the digital twin, you can start to identify those patterns and use instrumentation to identify problems even before they occur. And then a couple of other things, it can be used to help with health and safety risks, help maintenance activities be more efficient so you can deliver the right information to the person on the front line. Those are all things that it can benefit. You can identify bottlenecks in manufacturing, and use some of the simulation capabilities of a digital twin to say, what if I do this, or what if I do that? Can I improve? Can I break the bottleneck? And you start getting into investigations that can really result in better outcomes. Same thing applies for process manufacturing. Like I said, whether it's discrete or process manufacturing, obviously in process manufacturing, you're not going to be, putting an IoT sensor on a disposable beverage can, for example, but the process itself can absolutely be improved with a digital twin.
Mm-hmm.
There's a lot of opportunity there. And I'll step back for a second in the middle of answering this question and answer a different question. Then I'll get back to your first
Mm-hmm.
question.
Yeah.
There's an element of this that is implied, but I haven't said it explicitly, which is I've talked about the ability to monitor things with the digital twin and understand the state of what's going on out there in the real world. But there's a flip side to the digital twin as well. If the digital twin is sufficiently capable, you can decouple that live digital twin from whatever is going on in the real
Mm-hmm.
world and then say, okay, given these conditions, if I do this, what will happen?
Mm-hmm.
So you can decouple it and use it as a what if analysis tool as well. So that it's kind of got two sides to the twin. Going
Yeah.
back to your
I
sure,
love that you
please go
said
ahead. I
that
was on a
because
little bit of a rant there.
yeah. Oh man, sorry to cut in there, but yeah, what you just answered was something. Listening to you called out to me. It sounds like that there's different categories. There's the real time digital twin that is actively monitoring and helping make decisions on the fly, and then there's the predictive digital twin, which, just like you said, my understanding of it is you're fully simulating all of the factors of a complex systems, and now you can begin to uh, move different levers in different ways and see how the system begins to react to that type of change.
Yes, absolutely. And of course, there are limitations to that approach. You can't, especially with machine learning techniques, can't extrapolate outside of your training boundaries,
Mm-hmm.
but it can be a very valuable tool to use. Couple of other areas, energy producers, utilities, commercial real estate as well can
Mm-hmm.
benefit from this, that you can bring in, and this really plays to the flexibility of a digital twin. You can start bringing in things like GIS, geographical information system. So if you've got
Mm-hmm.
widely distributed assets or mobile assets, uh, not only is it useful to know where they are and what the state is, that can be incredibly useful if you're sending out a crew, for example, to do some work
Mm-hmm.
on something. You know the condition of the equipment, you can tie into the maintenance manuals and parts lists and have data
Mm-hmm.
at your fingertips on when was the last time a consumable or a part that needs scheduled maintenance was replaced, something of that nature. You can
Mm-hmm.
really just make field operations a lot more effective. Last thing I'm going to say, and then we can move on to the next question. There's also an opportunity for a digital twin to kind of provide value from a customer and occupant facing perspective. So if you've got a building, or if you have any kind of, say, you're a city planner and you're providing services to the public, essentially the digital twin can become the source of information that can help residents. Think about the occupants of an office building,
Mm-hmm.
the people who are actually in that building that you're managing, everything from emergency related issues to just improving the comfort and meeting the preferences of the people in the building. Now you can start delivering. You can deliver information to the occupants of the building. That you can start pulling a lot of information here. It's possible, even, although I haven't seen this personally yet, for companies to deliver even new services and revenue streams from the data available from a twin. So there's a lot of potential there. Like I said, I haven't been
Mm-hmm.
involved in a project that does that yet, but certainly the potential's there.
Yeah, I remember I did some work in Singapore for a bit, and I was really impressed with the technology infrastructure of their office buildings. And Singapore is very environmentally conscious in some
Yep.
ways. So the buildings were touted as green buildings, right? They have plants there, they have heat pumps and air exchangers to limit the use of electricity. And I would imagine, I didn't get to see how the back end looked like, but I would imagine it's trying to take all of these different signals from different data pipelines and then figure out what the most efficient way of managing the building is.
Yeah,
So,
it's interesting you mentioned Singapore too, because I've worked on a couple of projects with Singapore, and I've been to Singapore myself, and I was struck by exactly the same thing you were. I actually think Singapore is one of the more advanced countries in the adoption of digital twins. Part of it is just they have a unique advantage given their location and the highly educated nature of the Singapore population and the compact size and everything else. But also they kind of have an overarching vision and such, and have really gotten a lot of the decision makers in the community to buy into the idea of digital twins. So Singapore is actually pretty advanced on that front.
yeah, I really, have been thinking about ways that we could apply some of what they're doing to different cities in the US. One of the things, I was in Texas, in Austin during the freeze a couple years ago. And if you remember seeing a number of articles where it was talking about people without power, and then there were rolling blackouts between different districts. But if you look downtown, all the office lights were on, all of this spot, like these places were empty, the roads were closed, and now you're being told, well, we don't have enough electricity to portion out, but at the same time the city is all lit up.
Right.
Right.
Yeah, exactly.
So you can begin to assume the breakdown of data and management and automation for these buildings, and just seeing gaps where it's like, hey, technology like this exists.
Yes.
Why aren't we implementing it? And that leads right into my next question, because the things that you're saying of being able to pull data from inventory, work order procedures, ERP systems, GIS, things like that. What is the path for organizations to really even begin to think about implementing this stuff?
Yeah, I think it's a good question, and I think the way that organizations need to think about digital twin, implementing a digital twin is, first of all, don't think about the technology first. The technology is the enabler. It is peripheral in a lot of ways to the core issue. So you need, of course, to understand, what can a digital twin do? What are the capabilities? You have to have some idea what the latent possibilities are surrounding your needs. But an organization needs to start with the problems. And it's kind of a synthesis. On the one hand, you look over here, what are the biggest problems we are facing today? Or put another way, what are the biggest opportunities that we have for further improvement of our organization? And that's an important thing. So you need to, because if you're not solving those problems, it's very difficult to justify the management focus and the cost and the effort and such to necessary to create a digital twin, and not just to create it, but to maintain it over time. So starting with those problems, that's the best first thing. And of course, there are some problems that a digital twin isn't going to help with. It's not snake oil. And so you need to realistically assess, okay, is this something that digital twin could help with or not? Shorten down your list and come up with a short list. And then start looking at ways in which a digital twin could solve that problem. Look at other companies or other organizations that have implemented something. A plug for myself here, talk to consultants who have experience in this area, and really collect information. It's important to pull in other stakeholders, because oftentimes the barriers to implementing something like this are more organizational than they are technological. Silos are a real thing, and somebody else may either not understand or have some other reason to oppose an initiative, and that could really gum up the works. So it's really working through a lot of the soft side pieces of it first before getting into the technology. But then once you have that idea of what the problems are that can be addressed, then you look at things like, what's your IT and OT, operational technology landscape, look like? What initiatives do you have? What rules do you have around cloud and security and everything else? And then from that, that's where you start looking at architectures that can solve the problem. I just want to add one other thing. You need to understand as part of this, if you're creating a digital twin, who's going to use the digital twin and how will they interact with it? Not constrained by technology, at least at first, but really think about the people using the tools and how it benefits them. And, are there burdens that you're placing upon them? And think carefully about adding additional burdens onto anybody in their job. Solutions should be helpful, not extra work. From there, then you start looking at architectures, and that's where you start looking at the different solutions that are available. What kinds of data do you need to pull together to enable that solution? And then you start getting out into building out the project. I recommend that companies start small if they're new to digital twins, because there's a lot of learning to go on. But then once you've got that initial success under your belt, then you can scale much more comfortably, confidently, and you can also be much more confident in the business case to support a twin.
Yeah. Okay. So that's interesting. I'm hearing, a couple different parts, and one of them being, I like to go back to the idea of customer obsession. It's a little bit of the Amazon blood in me.
Yeah.
Right. If you're identifying the problems that you're trying to solve for, and you're figuring out if the solution that you are creating is the one that is in fact going to solve the problem and be used, you need to be thinking about your customers first. You're looking at the end case and what it is that they're facing and how you're going to improve that. And then the other thing on the cycle that I'm hearing is, you mentioned about organizational silos. And there's a lot. There's the technology silos, data silos, but then also the organizations themselves and the stakeholder silos and things like that. So in my head, I'm thinking back to the digital transformation journey I've worked with lots and lots of clients with. And, I get the sense a little bit of, if you get a client who is wanting to jump right into digital twin and they haven't really matured on their digital transformation maturity curve, it could probably start to expose cracks within their underlying strategy, organizations, and technology.
Oh, absolutely. Because if you're not aligned on that front, the problem is you're going to get 20% into the project. At some point within the project, these disconnects and lack of understanding or lack of agreement are going to surface and create problems on the direction of the project. And that's exactly the point in the project where you don't want to be bickering around, what it is we're doing here. You want to have that clarified up front. I could not agree more.
Yeah. So it's almost, build is the last thing that you start.
Yes.
The problem space assessment, and then I would even call it a gap analysis. You really need to understand what your assets are today, what your technology is like today, and find those gaps before you even get started. I would imagine, and we're going to start talking about AI right now. And you mentioned the word silver bullet. A number of times people are always looking for a silver bullet. Oh, here's a new, I remember when ThingWorks was getting really big and everybody's like, oh, drag and drop, aggregate any data source, you're done. It's a silver bullet. Like, we're just going to implement ThingWorks. And then they said, okay, do you have connectivity to the manufacturing floor? And they said, no, ThingWorks.
Yeah, exactly.
What's going on?
Yeah, so that's exactly right.
Yeah, looking for that silver bullet to almost skip the digital transformation journey. That's a hard conversation. Have you had that conversation before? What works in communicating? Like, you have to take a process that's going to be longer than just implementing the widget.
I've absolutely had that conversation because, people can have different attitudes coming into any kind of a project. And, so if someone is too forward thinking and too excited about the potential, they're going to jump right to the end of, oh, this is going to be great, and then forget all the messy middle. Whereas someone who is a little bit more antagonistic toward the idea is going to focus on the negatives and the downsides. And I think it makes sense to take a more realistic approach. And I'd mentioned earlier about kind of starting small, and there's a delicate balance there, because on the one hand, if you start too small and you're solving a trivial problem, then it's really difficult to get to justify continued investment in that, just because it doesn't address the core business challenges that I referred to earlier. It's fine if you're doing some just like a little bit of experimentation and learning and such. That's fine. You're really not committing much and you're just in a learning mode. But as soon as you start getting into trying to actually deploy any kind of a project, you've got to make sure that it is big enough to matter, but not so big that it's overwhelming. So it's a Goldilocks approach. And you know, your point about silver bullets is, you know, they work for vampires, but I've never seen them work anywhere else. It just it's a little bit of wishful thinking, I think, to just assume something is going to work magically.
Yeah, so I think that's a great lead into now with the rapid evolution of AI.
Yes.
And obviously AI has been around for decades. So, you know, AI has been there, but I think now there's such a proliferation of understanding of the things that AI can do that we haven't seen before, right? It's moved out of the realm of researchers in lab environments into people's homes in a very visible way.
Yes.
So, you know, thinking about where AI is going, how is that changing the evolution of digital twin, digital thread? Is it making it more of a silver bullet? What are the benefits? What's happening there?
Yeah, I think it is. There is real value, and in some ways, the capabilities of a digital twin mesh perfectly with the capabilities of AI systems. But, and I've got to underline the but on that, there's also the risk of combining something like AI with digital twins. You get the large caliber silver bullet. It's the ultimate solution, and it isn't always, because there are different kinds of AI. You still have the same basic problem of, you know, back when I was learning computer systems in the first place, garbage in, garbage out, that term still applies, because if whatever you're doing, if you're building it on unreliable or uncertain data, unless you're able to quantify that uncertainty in a very controlled way, you run the risk of getting unpredictable results out. So you still have to be thoughtful about how you apply it. But now, having said that, I think there's incredible opportunity with AI from a couple of perspectives. One is just, you know, AI is really great at pattern detection and pattern matching and, you know, predictive elements, depending upon the nature of the AI, being able to predict things based upon past patterns. And digital twins, particularly if you have sufficient model data feeding the digital twin and or operational data from, you know, the actual, you know, sensor data over time, and you're able to properly characterize that data, you've got a tremendous amount of really valuable data to help build AI applications on top of. So I think there's it plays to the strengths of AI. You know, the way I'd put this is, you know, say I'm going to make up a completely contrived example, but that you've got a process and you're receiving some material. That material can vary in some ways. You know, let's leave aside what the specific material is. You've got environmental variables that can vary the process and how it behaves. And then you're essentially, then you've got people looking at these different combinations of behaviors you could have 20 different factors that are affecting the end product that comes out of the process and the efficiency of the process itself. And without really the capabilities of something like AI to do that, you're kind of like hunting around with a flashlight in the dark. You know, you can look at one specific thing at one point in time, you can get a team together, and you can have people with enough understanding. Eventually you'll come to the solution. I'm not saying that's a bad thing to do at all. But then if you add on to that the ability of AI to start looking at correlations and factors in a much deeper way than anybody could, because, I mean, who of us can go through 20 megabytes of binary data, you know, and extract information from it? Not many of us. But AI can be very useful in helping to inform and accelerate those learnings. And a digital twin can feed the AI the information it needs to extract that value from it. You don't
Yeah.
have to have a digital twin to apply AI there, but hopefully we'll have a chance to get into later in the conversation the way digital twins are especially valuable at helping AI.
Yeah. Uh, let's definitely get to that. And I wanted to, make a note on something you said, the idea of teams going around and looking at data and pulling inferences from that and trying to figure out the relationships. And I mean, this definitely was the realm of this is what data scientists do. Yeah. But at some point, there's a limitation of the human capacity to take in all of the signals. And that's something that really excites me is, we call it artificial intelligence. I like to think of it as augmented intelligence, right? How do we augment the capabilities of that team that's looking for correlations in the data? And, I've been reading articles, I've been seeing some startups that have been basically just creating an engine that says pipe in all of your data and what type of inferences do you want to get from it? And we'll begin to see, okay, it's sunny here in Idaho and products are delivered faster because they can drive more hours in the day to make it across the state, whatever it is. But it's something that now finally, I think we're unlocking the true potential of big data because we've had all this data, but who's combing through it? Well, now we have a system that can comb through it and say like, oh, hey, I'm noticing these different trends, and then we can go in and dig deeper into it. So that's where I think, AI is augmenting our abilities is incredibly powerful.
I love that phrase, augmented intelligence, because it really plays to the fact that what you're doing is you're helping people do their jobs more effectively, more powerful. It's a power tool. And in many ways. It's just that instead of extending our muscles and bones, we're extending our minds. And it's incredibly valuable. I do think that digital twins, I'll jump right into the topic I suggested. I do think digital twins help in that regard, though, because all the things I talked about, thinking about the problem you're trying to solve deeply, thinking about the data that's being used, thinking about who's going to use the twin and how they're going to use it, that's, that structure that you put around it helps then focus, first of all, just the level of rigor you're putting into ensuring the data is good data. It's conditioned properly and scaled properly and everything else. Time stamps are lined up, all of the sorts of things that are necessary to make sure you're extracting the right data. That's all good. And you're doing that inherently as part of the digital twin. So you're almost serving the data up to the AI on a platter at that point.
Yeah.
And it makes the ability to develop these applications on top of the twin easier, I believe.
Yeah, absolutely. And, we talked a lot about data, and I think all the way 30 minutes ago, we kind of mentioned we're going to get back to data. So synthetic data, right? I mean, there's always been dummy data that we've all had to build testing data and do it. But now the rise of synthetic data, and I mean, it's a multi-billion-dollar industry, but, what's your experience using AI to generate synthetic data? I guess first, let's talk about what synthetic data is versus test data or fictional data or anything like that. So let's start there.
So I think the key with synthetic data is it is plausibly correct data is probably the best way to put it. You're generating the data synthetically, and whether you're doing that through just simple mathematical calculations, which depending upon the nature of what you're characterizing, you can do that, or whether you're basing it on an AI model that you've trained using some other data. Essentially, what you're doing is it's constraining the solution space you're generating, but you're generating plausible data. Good example is autonomous vehicles. So I don't know if you've worked with autonomous vehicles in the past. I've done some work in that area. And what's interesting, of course, is the problem that you're trying to solve is that you're trying to train the vehicle to respond to ultimately an infinite number of possible scenarios. And then you have to think about not only what are the normal situations that you're going to face, but also what are the corner cases. Good example. Man's walking a dog down the sidewalk and you expect that he's going to cross at the crosswalk, but maybe he jaywalks. Maybe he walks across in the middle of the street. The car needs to understand that and needs to understand that's something plausible. On the other hand, is the man likely to fly up in the air and fly over to the other side of the sidewalk? No, not in the real world. And so it's a matter of generating data that can be used by the digital twin, either in development or in production, in ways that are plausible. I don't think we've got time to get into the techniques for how to generate that, but things like GANs, generative adversarial networks, and things of that nature. But there are techniques that can be used to generate plausible synthetic data. But then once you have that data, it's useful, like I said, for production, because you can use it as this is what we expect, how we expect the system to behave. Is it behaving that way? But also for development purposes. If you're developing a system and you don't have the data you need to create the applications around that, you can create synthetic data and use that for test cases, for at least running through the applications and seeing how they work. So there's a lot of value to synthetic data. And that's another area, obviously, where AI benefits, because AI is incredibly powerful at generating synthetic data with the right guardrails.
Yeah, I think that would be an excellent follow-up talk, is synthetic data, how that's grounded in truth, and then what the different techniques are to get there. But, I've also seen benefits in things like healthcare data, right? Because we have so many regulations and concerns around the privacy of the data, but at the same time, it needs to have the right fidelity and the right feel of real data, but it cannot expose PII, HIPAA information. So I definitely see, these different techniques of generating synthetic data based off of original healthcare data, or some sort of confidential data, so you can get to the point. I love GANs and VAE, and I'm excited to talk about how that works, but getting it to a point where it is virtually indistinguishable from the real data, except it's completely fabricated, like synthetic data. And being able to unlock the ability for engineers and developers to build and test systems that doesn't require, hey, we made this update, it has to go to some far off QA process that has, somebody went through and did a find and replace on the names, and it's just, there's so many leaks within that.
Yeah, no, I agree. And I think that it's, the classic problem when you're developing something like this is you need the source data, whether it's geometrical data, boxes of different sizes that you use for training a robotic system, and what a box looks like, and what size ranges it comes in. Fine, you can generate all of those immediately, as opposed to having to come up with some other method for the data. So when you've got this data hole where you've got missing it, either because of, like you mentioned, regulatory issues around PII, or just the simple fact that you don't have the data, if you have a way of generating that synthetic data accurately, it's great. I work with a company out in Colorado, FS Studio, that they do a lot of synthetic data work. And it's amazing to see the kinds of applications that can be built on this. It's awesome. It really is.
And I would imagine, to what you're saying, with the person jumping over, from one side of the street to another, which, who knows, maybe we'll have jetpacks one day, but generating the synthetic data, it has to be founded off of data that you've already provided, or data that you can predict that you would need. I'm thinking back, autonomous cars, especially in San Francisco, where I am, there's this weird desire to put cones on the cars and do all of these things that, I wouldn't imagine synthetic data or AI being able to predict for these things, because it is an unpredicted behavior that, they didn't train the vehicles on, driving down at a stop sign and 4 people surround the vehicle and put cones on the cameras. So
that's because that's not anything that ever happened before
yeah.
the rise of autonomous vehicles. But yeah, you're absolutely right, and it's an important point. And I think you call out there are limitations to synthetic data because depending on you're using some system to generate that synthetic data, and depending upon how how that system operates, what it was trained on, what kind of constraints you put on it, you're going to get out a certain range of data. You may not capture 100% of the real world operating space. You can do so much better than you can without synthetic data.
Yeah. You know, that spur of the moment idea, Netflix's Chaos Monkey functionality. Have you heard about that before? Basically, there's a team in Netflix that designed a system that maliciously attacked their infrastructure and their application. And it would go through randomly shutting down services or adding latency or doing all these awful things.
Yes.
And they called it Chaos Monkey. So the idea is you will find the vulnerabilities of the system and be able to solve for them, because this thing would just go around doing unexpected things. I wonder if there's an iteration of digital twins where you're now creating chaos monkeys in your data. So like, let's go back to putting cones on the car. You could equate that to, oh, 3 out of 4 of the cameras failed. LiDAR is not working anymore. So if you had this chaos monkey component, just to say, okay, you've lost the data here, you've lost the data here, this is corrupt. How do you recover from that? That could be a way to have a meta solution, right? It doesn't matter how the data failed. It's just, okay, all of this is corrupt now and deal with it. What do you do in this situation?
That I'm really glad you brought that up, because I think on the one hand, I think there are a couple of sides to this. On the one hand, AI can be particularly powerful at anomaly detection, so you can identify when there are anomalies. But the other thing is, depending upon what exactly it is you're simulating faults in a system, where all of a sudden you've got an IoT network, and so you have a temperature sensor, and it goes out, goes belly up. So you're getting data out of it, but it's corrupt data. You don't want to make actionable decisions on that corrupt data thinking that it's good. So you need to be able to understand when the system is out of whack, and to be able to point out where that is. So actually, an important part of designing a system is to simulate those faults and to understand how that's going to behave within the rest of the system, and to be able to identify when, based on, like centrifusion techniques, based on everything I'm looking at, this doesn't make sense. Something's wrong. What could it be? And that actually can be very useful, because if any complex system, I don't care whether you're talking about an aircraft or a manufacturing production cell or anything else, things are going to happen. Things will go out of calibration, wires will break, something is going to happen. And it's really important, say, if you're in a production facility where every minute of downtime costs you tens of thousands of dollars, you want to get that fixed very fast. Or you could potentially run an entire batch of material if you're not if you don't have your eyes on it. So having the digital twin as your eyes on the system and being able to simulate and react to those kinds of faults, hugely valuable.
Yeah, and this goes back to what we're talking about, the real time and predictive, right? Get your system to a point that you can react in real time to immediate failures, then get your digital twin to the point where you can begin to predict future failures and solve for them before they even happen.
Yeah, exactly. And then you've just paid for your twin 10 times over.
Yeah, amazing. I love it. We have about 10 minutes left. I wanted to for the folks that are watching this, we do see the comments. So if you have any questions, feel free to type the comment and we'll put it up on the screen and answer your questions. I think it's really cool. We had a couple come in that I didn't put up on the screen, but it would look like this. So thank you for that, have a good scope. It's very validating for this first stream that we're doing. And then another one, an example, wanted information fence to fence, not just what is in the factory. What is the term fence to fence? Are you familiar with that?
I'm not sure what exactly what Chuck meant fence to fence, but I think what he's saying is just that I want to understand the entire picture, not just what you're
Yeah.
feeding me. If I interpreted that correctly, and Chuck, if I didn't understand that correctly, just let me know.
Yeah, I think that leads into one of the last points that we put in, some of the risks that you need to be aware of when you're implementing digital twins, and then even more so when you're now layering AI on top of that to discover and make decisions.
Absolutely. So I think, well, we already kind of talked about the organizational challenges.
Hmm.
So I won't go over those. The data quality and accessibility is important. So I talked about garbage in, garbage out. Um, Getting the right scope is important. I think the one of the things that is I think really critical is understanding the security implications of a digital
Hmm.
twin, because you're pulling data from multiple systems throughout a company. You need to have security designed in at the bedrock, at the foundation of the digital twin, and make sure you have your security architecture in place first, and that you're
Hmm.
implementing a digital twin solutions that rely on that security architecture, and you don't have any backdoors, because there are too many risks when you've got sensitive data, and you could potentially expose that accidentally. You need to make sure that that isn't possible. And
Hmm.
whether the data can be accessed in the first place, the roles and permissions for the people who can access the data, um, you know, how the data makes its way out to the end user device. There are so many different things. And if you have a digital twin where you're able to exert an element of control, then that's an order of magnitude even more critical.
Hmm.
So I would say that's something that everyone should keep in mind with their digital twin. Whether it's
Yeah.
on-prem, cloud, doesn't matter.
And I would imagine that in building this, it is subject to various biases that can be inadvertently in the data, in the decision-making trees that you're putting together.
Yes. Yeah, absolutely. So I think that bias is a real issue. I mean, we've seen with image recognition examples, you've seen some pretty well-known
Hmm.
examples of bias, but they're all generative AI. There have been examples of bias, and it's hard to even define bias, because anybody who's defining bias themselves have bias.
Or
So
bias, yeah.
yeah, but it's certainly something to, the bias, security, privacy issues that you brought up before. Things, depending on the nature of AI tools you're using, you have to watch out for hallucination effects.
Hmm.
Thinking about the scale and the cost and the benefit. Those are all key factors that need to be considered in a twin.
Yeah. It's funny you mentioned hallucinations. When I gave my talk about digital twin, digital thread, my colleague Pavel, I was talking to you about earlier, asked, hey, how do you handle hallucinations in synthetic data? And it almost caught me off guard. And I said, well, synthetic data is fabricated data. So as long as it's within the guardrails that you're expecting it, you want it to hallucinate,
Yes.
but in a very specific way. So I'm like, all right, you almost got me on that question.
Yeah, it's a
Talking to,
you. You're exactly right, because the if you're using AI to generate synthetic data, effectively the AI is imagining the data that is being created. It's a fine line between imagination and hallucination. So
yeah,
yeah, I think it's almost a matter of degree. I think it's a really good point you make.
yeah. So we have to come up with our list of topics for synthetic data because I think that'd be a really good conversation. I just wanted to close out. How do you get started on the digital twin journey, and what are some of the ways that you're helping companies? And before you get into that, let's see uh, what one of the comments were. So AI is almost mandatory to protect the integrity of your data. Yeah, absolutely. I think this goes back to, the example of healthcare data. right? And you still need the data, but you need to make sure that it's not leaking in ways that you don't expect.
Yes. Yeah. And if you can, I do agree. I mean, AI isn't mandatory, but it's almost, it adds it has the potential to add so much value for multiple use cases in digital twin that you have to consider it as part of the mix. You just have to. Maybe you don't use it at first, maybe you do, but if you're not considering it, then I think you're doing yourself a disservice. As far as how to get started with digital twins, I mean, the first step is just for anybody is just to educate themselves. Hopefully this live stream was helpful for a few people. But there are plenty of other sources. Your video that the presentation you gave in Bratislava was awesome, and that was I'm sure anybody can search on YouTube and find that. I thought that was a really good oversight. There are just a number of sources, but it's just kind of educate yourself first and foremost about digital twins so you have an understanding. Then the second thing, as I said before, find out what problems a digital twin can solve in your company that really matter. And then develop some support for it. It's that soft side of digital twins that you have to start with. And then I would encourage, hiring someone with digital twin expertise. The closer you can find someone who is the closest to your type of business or has worked with your kinds of problems before, the better. But what you don't want is somebody who has done the same thing the same way for 20 years and they're just going to cookie cutter it. You really want somebody who can come in and just understand your problems. And oftentimes a good way to do that is just start off with a small project, just a pure advisory consulting project to help you imagine the potential areas that could be solved and help reduce that set down to a set of realistic alternatives so that you can start the business justification process. Because if you're going to, a digital twin will cost money. The benefit, of course, is the objective is to either make or save a lot more money than you spend, but you're going to spend something. So you really have to make sure that you've got the business side of that nailed down as well.
Yeah, totally agree. I think approaching things in an experiment mentality, thinking what is that minimum lovable, feasible, viable product that you are trying to solve for, and figuring out where those cracks are and the gaps are and the benefits are before you cut a check for, a multi-million-dollar digital twin system. I think GE has spent in the hundreds of millions of dollars for their digital twin. Yeah, I mean, they have really cool stuff on their aircraft engines and things like that. So yeah, I love it. The experimentation philosophy and approach of have the vision, but start small.
Yeah.
And then start to build up to that and figure out what you need to do on the way.
And it's, I was at an event in Houston a couple of months ago, and a friend of mine, John Cunningham, was presenting there, and he put something up and he said, think big, start small, scale fast. And I thought it was a perfect way of encapsulating the mindset that you should have going into this. So you need to have that long-term vision, but you don't want to start with that, implementing that vision on day one. But once you do get something implemented, don't let grass grow under your feet. Move ahead, move fast at that point.
Yeah, that resonates with me a lot, right? For these larger scale transformation projects that I've been on and that I've helped clients through, and I'm sure you've seen this as well, they need to buy into the bigger vision, and then you're basically breaking it down into phases, but you need to make sure the buy-in is there first so that you can accelerate from phase 1 to phase 2 to phase 3. There's been certainly too many times where we've signed on for phase 1, and then I think the longest I've had was probably 12 months between the assessment and then the pilot. And it's like, well, now we just have to do everything over again.
Yeah, because you're exactly right. And people have lost interest, situations have changed. You're exactly right. It's important to move quickly, but thoughtfully.
Yeah. All right. Well, this has been great. Let's let's do a second one on synthetic data. I think we could do a whole other hour on just what that looks like and how that's generated.
That would be awesome. Thank you, AJ. And I'll hope everybody who is listening to this or listens to it in the future gets value out of it.
Yeah, absolutely.
Thanks again.
Take care, everyone. Bye.
Bye.